All right, so our next segment here is questions 8, 9, 10, and 11. And so 8 is, of course, the bottom of page 1. Then we'll go to 9, 10, 11 on the top of page 2. For these ones, we are going to be finding the particles, how many particles there are in each one of those. Now, particles could be molecules, could be formula units, could be atoms. We just want to make sure we're watching carefully what we mean by particles. So let's start with the first one. It says, how many molecules are in 0.6 moles of H2O? Well, we have 0.6 moles of H2O, and each 1 mole of H2O is 6.022 times 10 to 23 molecules of H2O. Okay, so again, we're looking for molecules, and molecules is one of the particles that we need to find. If we do the math multiplying across, should be something like this: 3.61 times 10 to the 23, and we're dealing with molecules of H2O. So we want to make sure that we are labeling each one of these questions clearly and carefully, and so that we have all the information on there. Let's go ahead, turn the page over to the top of page 2. And next question says, how many hydrogen atoms are in 0.6 moles of H2O? So again, now we want to kind of think through, okay, hydrogen atoms within a molecule. So we're going to do the same process we did for number 8, but we're going to add one more step to find the hydrogens. So we have 0.6 moles of H2O. And from here, we want to go from 1 mole of H2O is how many molecules of H2O, and that's Avogadro's number, so 6.022 times 10 to the 23. Now remember, the question isn't asking molecules, the question is asking hydrogen atoms. And we know that every 1 molecule of H2O has 2 hydrogen atoms. So that's going to be one extra step that we're going to need to go ahead and work through. So go ahead and punch that into your calculator. You should be able to come up with a number, and I'll let you go ahead and find that on your own. Question number 10 says, how many molecules are in 32 grams? So in this case, you're given a mass. In this case, we're given the mass of 32 grams of H2O over 1. Using the molar mass of H2O, we have hydrogen, there's 2 times 1.01 is 2.02. Oxygen is 1 times 16, gives us 16. Collectively, it adds up to 18.02 grams per mole. That's going to be our molar mass for water. So we're going to go ahead and use that as we answer question 10. And actually question 11 as well, but let's get through question 10. So we have 18.02 grams of H2O for every 1 mole of H2O. But again, the question is asking how many molecules do we have here? So we've gone from mass to moles. Now we need to go from moles to molecules. And we know that 1 mole of H2O is 6.022 times 10 to the 23 molecules of H2O. Again, I know these get kind of lengthy after a while when we're doing the math, but from here I'll let you go ahead and calculate it. You should have, just give you a heads up, 1.69 times 10 and then an exponent that goes above that. So make sure you have that exponent up there and labeling molecules of H2O. And by the way, if you round that to 1.1, that's totally fine. I wouldn't hate it if you rounded that to 1.1 as well. Final question here, and I'm going to set this one up quickly because I'm low on time. It says, how many hydrogen atoms do we have here? 32 grams of H2O. Our molar mass of 18.02 grams per mole. Then we bring in Avogadro's number, 6.02. And then finally, we're going to have 2 hydrogen atoms in 1 molecule. If my time runs out, please go ahead and finish solving this. Times 10 to the 23. 1 mole H2.